Whew. Okay, I think it should be streaming now, right? Nice. Alright. So today is the very beginning of what I call becoming smarter. So in my previous stream, I was going over some things I wanted to do over winter break, and most of the things I wanted to do involved a lot of reading and trying to better myself kind of mentally and maybe intellectually. So try to gain a lot of knowledge and also not forgetting some of the stuff I learned over this semester. So what I'm going to do for today is I have this book, this big ass black book called The Navigating Big Debt Crises, and also another one called Damodaran on Valuation. And I'm just going to read through some of the pages today. This is part of what I wanted to accomplish over winter break and be able to understand a lot of these principles and concepts that these two authors are writing about to hopefully become a better investor. And usually I think while I read, I'm going to also take some notes on Anki and also some notes on the book itself. And I'm going to create a new deck for Navigating Big Debt Crises. And then also another deck for Part 1, the Archetypal Big Debt Crisis. So I think that's what Part 1 is called. Okay. And honestly, yeah, let's just get started. The Archetypal Big Debt Cycle. And then after this, I think at 1 o'clock, Rudy's gonna call me, and we're gonna try to do some leak code together. So we'll see if that happens. Yeah. Okay, so let's see. And maybe create a deck. How to think about credits and debts. Alright, let's add. Alright. So since we were going through the terms, we're going to use the terms credit and debt a lot. I like to start with what they are and how they work. Credit is the giving of buying power. Buying power is granted in exchange for a promise to pay it back, which is debt. Clearly given the ability to make purchases by providing credit is, in and of itself, a good thing, not provided by to be a bad thing. So. So, how does Ray Dalio define the ideas of credits and debts? So, credit is the giving of buying power. Debts is the exchange of buying power for promise to pay it back. Navigating big debts crises. Okay. So credit is buying power, and then also debt is the idea of exchanging buying power, which maybe a creditor will give some company some buying power or some money in exchange for a promise to pay it back, usually with some type of interest. Currently, giving the ability to make purchases by providing credit is in and of itself a good thing, and not providing power to buy good things can be a bad thing. For example, if there's very little credit provided for development, there's very little development, which is a bad thing. The problem with debt arises when there's an inability to pay back. So differently, the question of whether rapid/debt growth is a good or bad thing hinges on what that credit produces and how the debt is repaid, how much debt is serviced. So, how
Is it only Julian that's going to be there, or will other people be there?
how can credit/debt be a good/bad thing? Called navigating big debt crises.
You should tell Toby.
Credit.
You know what's funny?
Credit/debt growth
I'll meet Kobe is at his wedding. Yeah. How do you expect that's the next wedding?
can be good in that it provides capital to create projects that increase productivity, but also comes at the risk of
Okay, that's fine. No, that's so fine. That's so fine. I'm asking.
risk of whether
Thank you. I'll cover
the
that.
debt can be repaid. So the credit/debt growth can be good in that it provides capital to create projects that increases productivity, but also comes at the risk of whether the debt can be repaid. Another way of saying this is the good/bad credit than debt comes from what is produced, how much can be paid back. Debt service. This is called debt servicing. So maybe this also comes at a risk of whether debt can be repaid. I'm saying this is that. Another way of saying this is. This is called debt servicing. Others, by definition, financially responsible don't like having much debt. I understand that perspective well because I share life.
And the
Even
stuff
when I
that
didn't
you
have any money, I strongly preferred saving because I felt that the upsides of debt were worth the downsides. So how can
Did you guys make symbols?
too little credit/debts? How can too little credit/debts credit is having too little
Yeah, no one is
credits. Call it buying power. That's exchange of call exchange of buying power. Have no buyback protection. Reduces the has an implicit cost of foregoing valuable and productive opportunities. Example of this could be not financing a public transit system because there is no credits being offered.
No, I finished that one.
Maybe that sentence sounds kind of weird. An example of this could be not financing public because there's no credit offer being offered. Exchange for debt, maybe. Okay. Generally speaking. Because credit creates both spending power and debt. Whether or not more credit is desirable depends on what the borrowed money is used for. That occurs the resources because spending is done. So credit, alright, credit can be a bad thing. Alright. Speaking of spending. How should one consider whether more credit is desired? So, more credits is desirable. Depending on whether borrowed money is used productively enough, generates sufficient income to service, repay the debts. Okay. Addressing the society. Fiscal conservatism is the part to do things is bad, which is not true. Okay, so sometimes. So, so we call this the So what are the potential trade-offs when with tight and loose lending standards? What are the potential trade-offs with tight and loose lending standards? Okay. So tight lending standards restrict people, restrict credit to people, businesses with almost certain that are almost certain to pay debt back. Tight lending standards restrict credit to people slash businesses that are almost certain to pay debt back. This can reduce the problem of loss on debts, but will likely reduce the potential economic from lending to less creditworthy. Probably loss on debts will from lending to less creditworthy institutions on valuable projects. Loose lending standards unrestricts credit to people slash businesses to anyone who wants buying power. This can increase the problem of losses on debts, but will increase the economic benefits from having more buying power, which creates valuable economic projects. Okay. Right, so there's definitely a trade-off between credits having an increase in the supply of credits, also having a decrease in the supply of credit. Okay. Suppose that you, as a policymaker, choose to build a subway system that costs $1 billion. You finance it with debt they expect to be paid back from revenue, but the economics turn out so much worse that you expect to only have the rest. So questions with $500 million. There's over 2%. To give you an idea of what might mean for an economy as a whole, really bad debt losses.
Today's we'll see you next semester. Yeah, definitely. Yes, I'll definitely do stuff like that.
So also too. Okay. So when looking at the economy of a nation, what are the figures that rate value suggest would what are the figures that rate what are the figures that rate value suggest would show me? Situation. Really bad debt losses. 40% of loans value that can't be paid back. These bad loans amount to about 20% of all outstanding loans. The losses are about 8% of all loans, and then total debt is twice double the nation's GDP. So the bad debt losses are 16% of GDP. So this flashcard I might want to kind of fix again. But yeah, this is maybe a typical bad debt situation. Okay, so I'm going to probably stop here for right now for the Anki flashcards, and then get working on the LeetCode stuff with Rudy. Alright. Let's see. Joining. Seven, 4, 3, 1, 3, 5, 5, 2, 6, 2. Okay.
Hello, Brian, can you hear me?
Yeah, what's up? I can hear you. Let's see.
Not not much. I'm good. How are you?
Oh, I'm chilling. I'm at the Sork right now.
You're at
Allison's
you're at
here
the
too. I think she's gonna go to work on her essay.
Leave my sticker for a second.
Okay. Okay.
Oh, are you still doing semester stuff?
No, not really. I was just working on this. I got this really interesting book about about Ted, and I was just reading that here and taking notes.
Okay, cool.
Yeah.
I was looking at Leet Code. I don't know if you've done this problem before. I know I'm interested in doing it. It's called add two numbers.
Add two
And it,
numbers.
yes, it's basically a problem where they give you two numbers,
Okay.
but they give you these numbers in a linked list, and you have to add them up.
All right. You wanna do that?
Yeah, and I didn't know this, but you guys have Racket in Leet Code.
Whoa. Okay.
That's like the language we've been using all semester in 430, dude.
All right. Let me see. Okay. So you said it's called add two numbers.
Yeah, add two numbers. It says it's medium difficulty.
Oh. Okay. How do I find it?
So I'm gonna try it because I just looked at it at 12:57 and I'm just like, oh, it seems interesting. Linked list, that seems like something you might want to use.
Oh yeah. Okay. You said it's called Racket or Bracket? Oh,
Oh no, Racket is one of the languages that you can use. I see they have C++, Java,
man.
Python.
Yeah, this looks so esoteric though. I have no idea what's going on with the syntax of Racket.
Yeah, I was gonna do a
Really?
Racket myself because I've been using it a lot.
Okay.
It's like OCaml, but you don't have to worry about fucking matching typing and all that stuff.
Huh. Okay.
It's nice. Way better than OCaml. But yeah, I'm
Yeah.
gonna try to do it in Racket since maybe it will work. I don't know, we'll see.
Okay, yeah, there isn't OCaml on this either, so
Yeah.
I'm gonna use Python 3 then. Let's see. Okay, so it's the one where it says you're giving a two non-empty linked lists, right?
Yeah.
Representing two non-negative integers. Two numbers are stored in reverse order, and each of the nodes contain a single digit. So, okay, two numbers and return the sum as a linked list. So the number itself. Zero, 4, 3, 4, 2. Bye.
No.
I'll see you.
Bye, Rudy.
Oh, hey, Allison.
Good luck.
Thank you.
Yeah. Ooh, yeah. This one does seem pretty hard, Rudy.
Yeah, that's what I'm looking at, dude. Because they're not guaranteed to be the same length lists. So I'm just like, oh shit.
Right, right.
So I'm just thinking of the case where they are the same list, and I'm trying to figure out how I would do this here. So
So I know for Python, I think what I could do is there might be some built-in commands where I can kind of split a number into. I can turn it into a string and then split it by character. I feel like that might be a lot easier in my case.
yeah, I'm thinking about how I would do this in Racket, because it would be interesting for me to try it in Racket. So I'm just gonna do a few test runs here. Um,
You may assume that the two numbers do not contain any leading zeros. Okay. The digits are stored in reversed order, and each of the nodes contain a single digit. Okay, so maybe I'm thinking maybe if you go through the linked list once, right? Then you could get the every single one of the numbers, and then I would just store that in some type of string, and then I'll reverse the string and then turn it into an integer.
I see.
I wonder, do you think you have any ideas?
What I'm thinking of doing with Racket is this. I'm just taking into account the case where they're both the same length. What I'll do is this. I'm basically just gonna go through one of the lists and then just add them all up and build another list in the recursive call. So I'm gonna be doing a little bit of a tail recursive thing.
Oh,
So, should I do a screen share?
sure, sure.
How do I do that again? Hold on, let me see.
I kind of forgot what tail recursion is, to be honest.
That's, I can't even see my thing. Okay, tail, hold on. Let me do share screen.
Also,
Okay.
I am live streaming, by the way. Just to let you know.
Oh, you're in lecture?
No, I'm in a live stream. I'm live streaming right now. So
Oh, okay. You're live streaming. Okay, yeah, you told me about that. I was just like, why are you in a lecture doing this?
nah, I'm not doing that.
Yeah. Okay, so can you see my screen here?
Yeah, I can see it.
Okay, so what I'm thinking, I also have Racket opened up here. But what I'm thinking is, so we have two parameters, obviously, N1, N2, which are supposed to be our two numbers represented as linked lists.
Sure.
I'm thinking of having a parameter here as a carry. So if we add two numbers up and they're greater than 10, then we'll have that be represented by the carry here, and then we'll have the new list right here so that it can be tail recursive. We don't have to wait on any previous function calls. So in Racket, what you want to do is something like this. So right now we're matching on N1, right? N1 is a linked list, and we know our our base case is going to be an empty list. If it's an empty list, then I guess we just return an L here, the new list. But if it's a cons A and a B, A is going to be the first element of our list, and B is going to be the rest of our list, right? So what I'm thinking is this. So we can do another function call here, add two nums. And what we'll do is this. This is what I think we're going to do. We're going to do add two nums, B, since that's the rest of the list there. Rest of N2, that's the rest of the N2 list. And then the carry, I have to figure out how we're going to do that. So basically for that, what we're going to do is we might actually even use a let here.
Okay. I'm gonna.
This is,
Okay.
oh, sorry, go ahead.
So is this? I don't really know the syntax, but is this the case where both of them are the same exact length?
But they're both the exact same lengths,
Is
yeah.
this kind of like the match statement in OCaml?
Yeah, it's exactly like the match statement in OCaml.
Okay.
So I'm hoping I can make this work in Racket. We'll see
Yeah.
though.
All right. While you're working on that, I'll try this Python stuff out then.
All right.
Okay. So I think we first iterate through the maybe traverse. Each of the link list, store the link,
Oh my god.
turn each character into a number. Each number into a character. Then add each number. Turn each number to a character. Add each character to a string. Reverse the string. Then add integers. Turn integer to string again. List node. Sum as a likeness. Turn the integer into a linked list. Okay, that's might be hard. Let's see. Traverse linked list. Self.
That's not right.
Oh, it works.
It doesn't work because it's giving 0, 0, 0 here, so I have to figure out what it is that I'm doing wrong here.
Okay. So this is going to be a helper function to traverse a linked list and returns a turns a call this a list. List of 2 whose first index is whose elements or lists of the reversed strings in strings each of the linked list. Okay, so we have while L1 and 2 dot value dot index is not
Kind of works here, but I have to figure out how to do the carry now.
okay, nice.
And also have to figure out the case for when there is...
So we have list
We're going to do the carry case at least.
okay. List 2 is equal to so L1 list 1 append f1 value. Then we do list2 dot append to that value, and then L1 is equal to L1 dot next. L2 is equal to L2 dot next. Okay, right, so L1 is none, then yeah, maybe I should do this actually. This might be easier. So just have to do two while loops. So just 3. So this will iterate through the first linked list, iterate through the second linked list. Okay, alright, and then we can maybe do list 1. I forgot. Okay. How to turn array of characters into string. Python. It's gotta be a function. Join. Okay. Join. So string 1 is equal to join, call list 1. So that should reverse it, right? List 2, okay. Then we return a list of string 1, string 2. Right. So we could say traverse a linked list. L1, L2. So we could say that's call. String 2 is equal to sum is equal to int string 1 plus int string 2. Okay. Print sum. Let's just see if this works actually. Oops. Let's just see if the print sum is working. Oh,
Okay.
shit. Valid syntax. Oh man, it is not. Maybe not. It's not. see if that works. Is not none.
Okay.
How am I gonna have to define it above? Ooh, okay.
I think I might almost be done with it. Give me one moment here.
Nice.
Okay, so almost at least done with the carry case.
Oh shoot, that's really hard.
Yeah, figuring out the carry cases was gonna be a little bit difficult here.
Traverse link list. Def traverse. Self, is it self? Oh, string
What?
dot file.
There's really like another case that I also have to worry about. The carry case, the case where they're not the same length, and also the case where what if we reach, hold on.
Okay. String dot file. So,
I also have to figure out the case where like if we add, let's say 9 and 9,
sure.
that's gonna be the end of the list. And we're gonna have 8 and then the carry bit of 1. So we have to make a new list that's gonna be bigger than our original lists. So I also have to
Yeah.
figure that out.
Ooh, yeah, that's a tough one. I'm thinking I just might create a completely new list itself. Unless,
Yeah.
yeah. Reversed sum is equal to sum, no, string sum, string sum, -1. Let's see. That will give us 708. Alright, nice. And then, okay, so we've reversed our string sum. Now what we need to do is create a new list. Okay. Oh, right. How to split string to characters. Python. Oops. Use the unpack. Really? That's all it does. Unpacked sum is equal to star reversed that really gonna give us what we want? Oh my god, it is. Okay. Okay, so we'll call this sum list is equal to list node. List node of values equal to. Sum zero string test int, and then we after converting into an int, we also want next to be none for now, and then
You think you're almost done?
I don't know yet. So right now I'm working on the part. I have the final. So what I'm doing is I'm storing an array of strings. I have the final array of reversed characters I need, and I just need to input that into one of the list nodes so that I return the final sum.
I see.
I think I might be able to do this. Let's see. I have to figure out how to kind of instantiate this and how I can iterate through. Alright.
Yeah, that's what I'm thinking too here. I think I'm off by one here.
Of unpacked sum list plus equals new list equal to okay, so we might have to keep a pointer at the head. Alright, so new list is equal to create a list node of int to values equal to ints unpacked sum. Call this one I value none. Head is equal to list is equal to head. Right. Sum list.
Damn,
Next.
we're running out of time.
Alright. It's game time. It's game time. Okay. And then we iterate. So sum list. Sum list is equal to list head Okay, so I got something that kind of works, but it's saying that my thing is super slow, which is not that great.
Does it work for all cases?
It seems like it does work for all of the cases though, which is good.
Damn, that's really good, man. I'm still doing this shit here. I'm trying to figure out if this is right or not, but let me see. I
So
think this might be.
the thing is though with my thing, it is kind of hacky because I'm not really doing any of the matching or carries that you're doing.
Yeah, I
It's
think mine's. I just screwed it up with the binding for C2.
I hope so. I've seen like two.
Let me think here.
yeah. I'm also gonna try to do it your way too because I feel like it's probably that I might get stuck on with you actually. Let's try. So what's the logic behind the carry that you're working on? So like with that 9 plus 9
So,
thing, how do you even account for that?
yeah, that's what I'm thinking. First of all, I'm just trying to make sure I have the right carry number to at least carry it on over.
Yeah.
I'm tackling the case with the carry. Because like if you add 4 and 6, like for example, 3, 4, 2, and 4, 6, 5, the output should be 807. Um, but when you add 4 and 6, that's going to give you 10. So you're supposed to have that as 0, cons that to the new list, and then change your carry bit to 1. I think with what I'm going to do with the carry bit is just at the very end here, what I
Mm.
can do cons C to the NL like that. Because if we do 9 plus 9, that'll be 18. And then these lists will be empty. And so we'll basically have 8, and then we'll have a carry bit of 1. So we just cons that 1 here to the rest of the list, which should be 8 in the empty list.
Okay.
So I'm trying to think right now, though, how the fuck would I do the carry bit, though? I mean, how the F I would do the carry bit,
Yeah.
though.
How would you first? How would you get the reversed integers to add? You know what I mean? Because
Well, we're given the list in reversed order. And that way that when we run it and return the list, it'll be in the right order. So like you see here,
yeah, can you show me?
3. Oh, sorry. Are you able to do
Yeah,
I
yeah,
have?
I can see your screen.
Okay, so you see where do you see what I have highlighted here?
Sure. Yeah, yeah.
So 2 plus 4, that's 6, and it's given to us last. 3 plus 4 is 7. That's supposed to be our last digit. So like we're giving them in reversed order. So all we have to do is just add the numbers up and then just build the list up. So we don't have to do any reversing unless at the very end they want us to display them in reverse order. But there's no need really to reverse anything.
Okay.
So right now I'm just thinking of the case, how am I going to determine what our carry bit will be? So if A, the first number plus the first number plus the carry bit is greater than or equal to 9,
We're not gonna leave the airport, but I just wanna like explore the airport.
then we're going to want the carry bit. Mm,
Yes, it is so like I like it's not just hot, but it's like humid too.
I'm thinking.
Oh wait, Rudy. I think they're.
During the summer it's
Huh.
dry.
I think this might fix it. I don't know. We'll see.
Wait. So can you explain to me what the list means again? List 342.
Oh, this is just basically quickly making a list. So like you don't have to type in cons 3, cons 4, cons to empty list.
So
That's basically what that does.
does that mean that the 3 is the first element
Like I was
in our
like,
list?
Yeah,
constantly sticking.
Okay.
yeah, it's the first element in our list.
Yeah.
Because in this problem, it's saying that 2 would be the first element in the list. Right? It would be 2, and then 4, and then 3.
Let me see. So hold on, let me copy this code because I think I just at least figure out the case with the carry bit here.
Okay, sick.
So hold on.
Yeah, yeah, yeah.
But it's like a little bit more north. But that place is actually kind of cool. Like I more really like that.
I got something wrong here. Hold on.
We're, like right next to the equator, so like that makes
It's like a syntax thing, maybe.
But
Yeah, it's a syntax thing. Let me see this here.
like it's just
Okay.
always like summer. Like everyone goes outside. Like there's so much happening all the time. It's loud. Yeah, it's been fun. You know, just decided to try more street food, or just like food. Because when I went last winter, my grandparents would sometimes cook, like my aunt, and I'd have to eat at home. But like this time, I want to like try more foods outside. Yes.
Oh my God, I've already spent so much time on this problem.
No, so
Nah,
Let me
nah.
see though.
It's okay. This one's a hard one to kind of just jump into, to be honest.
when I was like 5, and then there's a 14-year gap, and then I went last winter.
So the input is supposed to be
But I never felt like
list
last time
243, list
but
564,
actually like talk to my cousins and stuff.
Alright, let's hope.
and 0 and empty list, and we get
Nice.
807.
Nice.
Okay, that's nice. So now I just have to figure out the carry bit, and that should just be as simple as this here. So if we do cons C and L, but let me check if that's right. Let me see if that works. Okay, so it still works. So let's do add two numbers, list 9 and 9.
You're not doing like a tour.
Ah,
Shit.
it has 9 and 8, and it
It's
shouldn't
close.
be 8. Yeah. So
Why is
there's
it at 9?
something wrong with my logic here, I think. We do 9 plus 9. That's 18. Basically, what I'm doing for the carry bit here, I believe, is... Let me see.
Right. Oh, that would need to be 1, right? So your carry bit would need to be 1.
Yeah, it would have to be 1. Let's just say we do cons 1. Well, let me make sure that I have this right, I guess. Let me see what we're doing. Okay.
Oh, what if you do, let's say,
So it's 18 now. So there is a problem with how I'm defining the logic for the carry bit, I think.
okay. I wish I could read through, but I have no idea what's going on with this rackets shit.
Yeah, dude. So you already figured out the case with the carry bit?
No, I didn't. I'm trying to understand your code, but I have no idea what's going on with racket. Like, I don't really understand any of this.
It's just like OCaml, dude. So basically, you have your function defined here, right?
Okay.
And then you have the function name right here. The first thing is always going to be the function name, and then everything after is going to be the parameters.
Okay, I could get that. And then once you hit the match statement, then I could start to kind of lose it. Oh, man. The Rudy's thing ended. I might have to join back. Let's see.
Everything else is just like.
Oh, meeting passcode.
Sometimes I would like put exceed. Yeah.
Shoot. Shoot, okay. Rudy has to. I'll start one then.
Also, that's like really chill job.
Okay, that means I should probably create one. Because Rudy can't start one until 9 minutes later. Alright, so let's see. Participants, invites, copy invitation. I'm just gonna send it to myself on Discord. Or messages. Fuck it. Let's see, Brian too. Okay.
Oh, it was cute. So just like they're. I mean, I need to get to know them better. But no, I didn't. 'Cause I already have a little. I was like, I don't wanna. Like, I don't think it is like have a little one. But yeah, it was fun.
Me know if this works.
It was so good. Like some private lake in Virginia. I think it's always like that. Yeah.
Oh man, I just got news that Nicola. Oops. Oh yeah, working on leak code with Rudy.
Oh yeah. Wait, how do you know Jen?
Like a bunch of stuff, but she's now used to
Nicola. Owner.
She's so bugging. Yeah. Her superlative was most golden retriever energy. Like, it's so true.
Oh man, it's at 90 cents. Fuck.
Do you guys have a task retreat?
oh yeah, that was like
Where'd you guys go for?
I don't know, I didn't go. You guys were Pennsylvania. Or Virginia. Are you gonna go to the USA?
No. I'm like not really involved. It's like it's kind of bad, but it's not. Cause all like basically my whole BSA fam or like my immediate BSA fam, they're all like quite annoying. So it's like I feel like I see them enough, so it's like whatever. Yeah, I feel like
God.
if I went to a BSA event now, I wouldn't know anyone. It's a bunch of new people.
And that's how I feel about Paso. The freshmen in Mason don't know you. They
Yeah.
don't like talk to them.
Yeah, exactly. Like I just like don't really, I like avoid BSA events.
Yeah.
I don't. But even when I was a
Okay,
freshman,
Rudy's having trouble
I
getting
knew
in.
people and my friends there, but it was still like really hard. Like it felt like cooking all the time. So I don't know.
Say you do. This Zoom thing is kind of ass, honestly. Goddamn. Maybe Rudy has Discord. If you recursively traverse. Rudy doesn't have Discord. Shit. Burden next time. Oh, I see. So there is a way to kind of get the carry. Alright, yeah, it seems like Rudy's not able to join, so I'm just gonna end this meeting. Alright, end meeting for all. I'll just wait until he comes on. Okay. In the meantime, let me think about this. So, this actually is kind of optimized for going through and traversing each of these lists, but also adding. Okay, so maybe we could traverse. So, traverse both lists at the same time. And then each time we create, we add the digits at the corresponding location. Okay, so we add each digit, so let's say 5 plus 2 is equal to 7. Alright, we'll move on to the next one. 4 plus 6 is equal to 0, is equal to 10, but that means this becomes 0. And then we add the 1. Okay. We add the 1 over here. We add this, and then we add the 1. Alright. So there need to keep track of carry 2. Maybe there's a better recursive solution here. Track of the carry in order to add. So maybe do this recursively. So try to create def two numbers. So do self L1. L2 and a carry. It'll output a list node. Alright. So this one will two numbers and a link as recur simply. Okay. Right, so if L1 is none and 2 is none, then we just return. Oh, we gotta keep building, right? So maybe we can keep track of our sum list. Okay. Return sum list. So this is gonna be our base case. Base case when we reach the end of both L1 and L2. So if that's not the case, so alright, if L1 is not none and L2 is not none, maybe so else if is not. Okay, I think I'll do this one first. This one works best for me logically. Is not none. Then we do a 1 dot value plus 2 dot value. So we do sum is equal to, we'll call this a digit. Sum is equal to 1 half. So we need to mod it to mod 10. So carry is equal to 1 if digit sum is greater than or equal to 10, else 0, and then true. Single digits. What should I call this? Is equal to L1 that. Okay. Let's up again on Rudy's. I'm gonna join his. So QR2385BN VJ. Okay. Yo, what's good, Rudy?
Oh, hey, what's up? Can you hear me?
Yeah. How's the progress going?
I tried putting it in the little thing here for LeetCode, and it says there's a runtime error. I think they might be doing something different in Racket. I'm looking at their definition for singly linked list. So they're saying,
Sure.
oh, there's a value next. I don't know what it is that they're saying here, but
Yeah, okay.
it looks like they're using the make list thing from Racket, which I haven't used before. So it looks like I'm just gonna mostly do the testing on this one here.
Okay.
But I think, and I was spending a few minutes working on that, but I think I might know what's wrong with what I'm doing for the carry bit. So
Okay, nice.
let me think here, because it works with the case here of 243-564, you get AO7, right? But then if you do this, list 243, list 5740, empty list, you get -117. and that's not right.
or not.
So I'm thinking about how to solve that because I think there's an issue with how I'm doing the carry bit. So the carry bit is either going to have to be 0 or some number that's a leftover.
Hmm. Yeah, I've been thinking about this problem because I think it can either be 1 or 0, right? If we're adding.
Yeah, yeah, I agree.
I'm gonna try it.
Me-
Yeah, I'm gonna try that. Yeah, this is hard. The thing that you're trying to do is hard. I'm having a hard time with this too.
Yeah, it definitely is hard. I think I might give it maybe 15 more minutes, I think.
Okay,
And then I'm gonna probably take a break
sure.
because, yeah, dude, I also gotta review some other stuff about data structures. Did you know what a trie is?
A tree with, is it a tree?
TRIE.
Yeah, is it? Does it relate to a tree, or is it a tuple but has 3 things?
It's supposed to be related to a tree. Yeah, last night I was reading up on some data structures that we should know,
Yeah.
and they were saying like on some interview questions, you might get questions like, "Oh, um,
What is
try
a
to
tree?
sort a list using a stack." How the fuck would you order a list using a stack if you can only push and pop?
I have no idea.
Yeah, dude. So I'm just like, God damn, I got a lot of shit stuff to review, you know?
Yeah.
And even just this medium problem is giving me a tough time here with Racket.
Okay, well, that's because you're using Racket. I feel like Racket is such a esoteric. Oh, with all these questions, the functional languages is gonna be pretty hard.
But I like a challenge. It's not fun when I'm winning.
Oh, it's not fun when you're losing too.
That is true.
Jump on that Python wave with me. Or C++. You wanna try C++?
Maybe.
Okay, that's another language I want to get good at. I want to get good at Python and C++, C. I think with those 3, I'll be fine. I don't need any other languages.
Yeah, I'm gonna try to get good in Python, and then I'm gonna try to get good in I think I'm gonna practice a little bit of C sharp in case I get the internship for
Mm,
the IRS
nice.
and SQL because they also want SQL, I think. So SQL, C sharp immediately, and then C++ because that's a type of question that I got wrong on that interview.
Okay. Also, I'm kind of glad that maybe WMATA didn't really work out. I don't know if you've been hearing recently, but they're having some big budget issues.
WMATA?
Yeah.
Oh, I don't even know that.
Yeah, I think they might be laying off a lot of people. And
They didn't even have any computer science jobs when I applied. They were just like, oh, just apply to whatever job you see there, and then we'll have your resume and we'll contact you.
yeah.
And I guess that is kind of how they work because that's how I got my job at the call center where I worked at for a few years. Like,
Yeah.
I'd applied there, but they didn't really respond immediately until like a couple months after.
Yeah, that's fair. I just hopefully it won't be hopefully they're able to figure something out because I think they would have to cut a lot of jobs and then also reduce some of the hours and close down some metro stations, which would kind of suck. I like
Yeah.
using yeah. But let's see if this maybe if we do this problem, then that's gonna solve their problems. Let's see. Sum list dot sum. Okay. So we have a dot next is equal to Oh man. Yeah, doing this recursively is hard. Oh shoot.
Yep.
How do I keep track of the head?
Well, you don't. When you're working with lists, usually you're given the start of the list and you're supposed to go until you reach the very end, which should be an empty list or whatever marker you have designated to let you know, okay, this is the end.
Right, but if I want to create a new list in return, if I return that list recursively, then I would just be at the tail of our list, right?
Well, you're starting off from the tail of your list. So like that's why whenever you see me doing this here, like when I'm building up the new list, new NL
Oh,
new
I
list here.
can't see your screen right now.
Oh shit, sorry about that.
That's
How
okay.
do I do share screen? Okay. Okay, so like when you see here, the new list that I'm building up here is NL,
Mm-hmm.
and I'm passing in an empty list because that's supposed to be where you're starting off from, because really you're just kind of building up a list starting from the very end, which is the empty list, which is why it's given to us, which is why the result is given back in return. So like 243, 564, those numbers are reversed, but when you append them together and make the new list, it's going to be in the right order, 807 reversed.
Mm-hmm.
So that's really it. You should really take 430 compilers if you want to learn more about that stuff. It's
Yeah.
very interesting.
Yeah, how'd that class go? You guys had a final project, right?
Yeah, dude, I spent so fucking long on that final project and I don't even know how I've done yet.
Oh,
Because
you still have to do it either today or tomorrow?
no, it was due Saturday, but it's just they're just like the little thing that they give you to see if your project is right or not.
Yeah.
They only do structural tests and they have all the secret tests.
Oh,
So it's basically all secret tests. So you just
I
have to
see.
do a lot of testing yourself to make sure that it works right. And I don't know if I tested out every case that I should have.
Mm-hmm.
So that's why I'm a little bit worried about that. But the te cases that I did test out, it was good.
Okay.
But I don't know, man. We'll see.
Yeah, yeah. I think you'll do pretty good. I mean, seeing that you kind of understand all this racket stuff, I think you'll be fine.
Well, Racket is just what we use to generate the assembly instructions.
Oh, you also have to comprehend the
Yeah,
assembly instructions too.
yeah.
Oh shit. Oh shit. All right, maybe I should take this class to understand what's going on.
Yeah, Racket is a very small part of the class. Like, I will say that.
Okay. Alright, so what if I have true digit sum equal to place node true digit sum none. So this is where we greater set the sum list to next list. Set up the next node. Okay. Turn sum
Damn it.
head. Next. Two dot next. Carry.
Oh, you're working on it.
Hit that next. Go
Okay,
ahead.
I was gonna say, I was only left right now.
Sum list dot next. Okay. Alright, so this is where we call. Alright. now we have the case where L1 is none and L2 is not none. Then we do.
Well, at least I think I know what to do for the case of 9 plus 9 where we need 18. Basically, if our carry bit is greater than 0, that should be greater than 0, then we'll just cons 1 to the list. Otherwise, we'll just do the list. So it works for 9 plus 9. But now I have some errors here with this.
Okay, let me see. Oh, wait. You're getting a negative thing?
Yeah, I'm getting a negative number because of what I'm doing for the carry bits, I think.
So carry LC2 if greater than or equal to plus.
So 2 plus 5, that's 7. That's okay there. 4 plus 7, that's 11. And we get the 1 there, and we're supposed to do the carry of 1. 3 plus 4 is supposed to be 7, but we get negative 1 there. So...
Oh, are there negative integers in here too? That's...
I don't think so. But that's
Oh,
just
yeah,
a
yeah.
bug in that's just a bug in
Yes.
my program.
Okay.
So I'm just like, oh god damn it, there's 9.9 million submissions and 4.1 million accepted.
Okay. Probably like 0.0001% are actually in Racket. I would assume maybe like less than 1,000 are. I don't even think 100 submissions are in Racket. I'm surprised they even have that. I'm not gonna lie.
Yeah.
Alright, I think I'm cooking, Rudy. I think I'm cooking. Two is done. I think this code could be written better, but okay, so if carry is greater than 1, so this dot next is equal to this node 1
Okay, I think I maybe fixed it.
900. Nice.
Let me see here. So 2, 4, 3 plus 5, 7, 4. So 2 plus 5, that's 7 at the end here. 4 plus 7, that's 11. So 1 here, and then the carry bit is 1. 3 plus 4, 7 plus 1 is 8. So that's good right there. But, and let me see here. And if we do add list 9, 9, that also works. So it's 9, list 9, we get 18. And I guess if we do 8, 17, what if we do 1? Get a bug there. Yeah. Okay. Well, there's definitely a little pickle here.
Yeah.
I
Me too.
can't have this here set to greater than or equal to 0 because that means it's always gonna append 0 at the very end. So like if we have,
Okay, wait, let me see.
it's always gonna append 1 rather.
Hmm.
So that's the problem with having with this with greater than.
Nice.
Yeah, so I have to figure out how to solve that bug here.
It has to be greater than 0.
Yeah, it has to be greater than 0. If the carry bit is greater than 0,
Okay.
that means we have something to carry over. And we don't want to necessarily add that carry because like what happens if the carry bit is 8, right? Because like when we did add 9 plus 9,
Mm.
I think the carry bit was 8. But you're not going to say, oh, it's 98. Well, you're not going to
Wait.
say, oh, it's 89.
So why would the carry bit be 8? I would think it would be 0 or 1.
You're right. The actual carry bit itself is supposed to be 0 or 1. I
Mm.
have to add in another parameter here. I mean the leftover, whatever you call that.
Oh, the remainder? Like the
The
mod?
the remainder, yeah, sorry.
Yeah.
I kept calling
No,
it
no.
the carry bit.
Honestly, I'm not even too sure if it's called the remainder either. Because I feel like that's for division, not addition.
Whatever you have,
Yeah.
oh my God, like whatever that number is called, what is it called? The adding, the extra adding number or
Okay.
whatever, you know?
Sure.
I don't know what you call it, right? But like you need that for like the cases of like 817, where it's just like you add to the 4 and the 7,
Yeah.
11, and then you carry 1 over. I guess the carry. Oh, is that what I'm calling it? I don't know what you call it, but anyways, I was also thinking about making another parameter here,
Yeah.
making it an actual carry 1 or 0.
Right.
But then I'd have to change the rest of the logic here, and I'm just like, ah, damn it.
So with the C that you're using right now, are you like the carry? Oh, so like a 9 plus 9, that gives you 18, right? And you said 8
Yeah.
is the carry. That's
Yeah,
the number that you create a new list node for, right?
yeah. But
Okay.
it's buggy because when we do 9 plus 1, it's supposed to be 10, but it only does 0, as you can see right here.
Right. Okay.
Right, but if you do, oh, 9 plus 2, oh, it's 11, and so on. So it's just that very one case.
Yeah, it's hard.
Yeah. I guess maybe I should get better with Python.
Yeah. Well, I'm having. I think might have a solution for the problem you're having, but I'm having a problem with the recursive step. I still don't fully understand how to return this entire list.
Well, are you doing it recursively in Python?
Yeah. Could I share my screen with you? Maybe you might have some tips.
Yeah, go ahead.
Oh shoot. Okay, wait. You might have to let me share my screen.
Let me see here. Uh, okay, can you share now?
Let's see.
Are you still at UMD?
Yeah, I'm at Snap right now, actually.
Okay, I didn't even know they were still open.
Yeah, I think it closes tomorrow. All right. Let me try to show you exactly what I've kind of been cooking up. So the idea is to do kind of exactly what you did. I want to try to do this thing recursively. So I have this helper function that's is called add two numbers recursively, and it takes in the lists 1 and 2, the carry, which I think you and I have different definitions of what the carry is, the head, which I don't know how to actually use this yet, and then a sum list. And for this function, I pretty much have 4 different cases. So when L1 is none and L2 is none, that's pretty much when we've reached the end of both of the lists, and then I just want to return the head of my list. And I want to make sure that the carry I'm using, whether it's going to be greater than, if it's equal to 1, or if it's equal to 0. And if it's equal to 1, then I want to make sure that I'm getting that extra 1 that needs to be at the end of my list in order. So let's say the 9 plus 9 example, I have to make sure I'm capturing the extra 1 and then adding that to the end of my list. And then I return the head of my list.
Right.
Okay, so now that's the base case. The other case is when both L1 and L2 are both not null. And so in that case, I have to add both of the digits itself. And so I'm adding both of the digits. And then this on this line. So to add both digits. And on this line, I'm setting carry to
bit.
1
It's either 0 or 1.
if the sum is greater or equal to 10. Else, then if not, then 0. So that's pretty much what this line is doing.
Right.
And then the true digit sum is a variable which it's the mod 10 number that should be the digits in the node. So this would be our 7 or 0 or 8, whatever is left over if we divide by 10. So
Well, modulus 10, right?
yeah, the modulus thing. So maybe a better word for this would be the remainder. Or it says remainder. Okay. And then this is where I'm kind of confused on how. So I have, then I create this, so I have my sum list, right? And then I'm going to set the next node to the list node. So I'm going to set it to the remainder. And then I'm going to set the next node after this to be none. I don't know how to keep track of the head of my list so that when I get to the base case, it returns the head and not just the sum list. Because when I call, so I'm calling the recursive function here, but I'm calling it on sumList.next so that in the next call, when I do this line, I'll not be replacing the existing list node, but I'll be in this list node so that this none will be whatever is after. Does that make any sense?
Yeah, that's an interesting thing there, though. I was looking up some of the syntax for Python before we started really quickly, and don't they just have like a little is list node something that you made yourself, or is that something that's already in Python? Because I was looking at their little list thing. Don't they have like a list where you can do make new list and then you can just do add the value and it'll add it to the end there?
Oh shoot. Maybe because I was just using the class that they defined here. It straight up has two things.
I see.
A dot next and a dot value.
Okay, so they have their own little thing here defined. Let me see that.
Yeah.
Yeah, I think that's also what was tripping me up for the LeetCode thing when they were defining the linked list. And they had F, but it couldn't work with their code. But let me see here.
Yeah, I don't even. This just has two things, a value and a next node type thing. Interesting.
Yeah, that is interesting.
So You see what the problem is, right? Like, how do I keep track of the beginning of my list, even though I'm making these recursive calls? Hmm.
Well, the value and then the link to the next one. So in Racket, well, in Python, I don't know if you're building it from the very end where you're pushing onto a stack, or if you're doing it differently where you're starting from like the beginning. Because in Racket, when you build a list,
Mm-hmm.
when you get the input, it's gonna end up coming out quote unquote reversed
Mm.
because you're pushing onto a stack
Okay.
whenever you do a function call. But with this thing of like but with this here of Python, I'd have to go over it, but I don't know if you're building a list from the start, the very first element, or from the tail.
I think this one is going from the very first elements. So it'll build 7 to 0 to 8. And then the problem is I return 8 instead of returning 7.
You return 8 instead of returning 7.
Yeah, let me double check if that's actually happening, actually. So sumless. I actually haven't run this yet. Takes 3 positional arguments, but oh shoot. None. Okay. Digits sum.
Maybe you should try using Racket because I think it's easier with all the recursion and pattern matching.
No. I don't think so.
I don't know, man. I'm just saying my Racket at least works.
Okay, sumless. Maybe I need to go through some of this stuff because. Oh, it's because.
No, I'm not gonna lie, dude. I mean, I'm not gonna lie, dude. I'd have to also go over how to make lists again like this because I haven't done this since Java, like 132, I think.
Yeah. Oof.
God damn, we've worked with so many different programming languages, dude. I've worked with Java, I've worked with C, I've worked with MIPS, Ruby, OCaml,
Bro,
Rust, Racket this semester, Kotlin this semester, JavaScript this semester.
Oh my god. There's no way you remember everything. I forgot like half the shit I learned. More than half.
Dude, I don't even remember everything either, dude. Like, the Java, I remember some of the simple syntax for it, and I remember how to make array lists, but I don't remember how to actually do the structures for the linked list because.
Oh, yeah. But maybe
I
it's
don't.
just syntax. Maybe it's like, okay, you can't remember everything for syntax, but once you read over some documentation, then it should just click again. Who knows?
Like, the value part makes sense, but the reference part is what I'm wondering. Like, that's my only thing.
Right.
Because in Racket, it kind of does all of that for you.
Mm-hmm.
So you don't really have to make those data structures. So yeah, I'm just like, I gotta get better with the making data structures thing again.
Okay, that's fair. Wait, line 92? Wait.
By the way, I think I'm gonna stick around for maybe another 7 minutes, and then I'm gonna hop off.
Okay, yeah, that's fine. Add two numbers are cursive. Oh, do I have to do this below? Maybe I do actually have to. Above.
Maybe you have a typo somewhere, but it does say it's not defined.
Yeah, I think it's because I might have to define it above the function I'm calling it in. Let's see if that's the case. Oh, maybe it.
Add two numbers or cursive.
It's not.
Line 27, line 57, and 83. What does it say on line 27 though? Return.
Add two numbers or cursive. Am I not just calling this right here?
Well, have you already closed that?
Oh, I think the problem is I'm forgetting this actually.
Self that? Okay.
Yeah, this is something that happened last time. None type has no attributes. Oh, shoot.
Digit sum is not defined?
Oh my god. Okay, there's so many these syntax bugs. Oh my god.
No.
God damn.
Damn, this seems tougher than OCaml.
Okay, I'm being lazy though. I think I know why. It's because I'm not doing this stuff. Okay. I'm forgetting the small things.
And you're still streaming on YouTube?
Yeah, I am.
Oh dang, dude. How many viewers?
0. Oh no. So I'm getting. Oh man, yeah. Okay.
Wrong answer.
So I'm getting 7, but not 0 and 8. Ooh.
I think you should try Racket.
I don't know about that.
I can teach you the way.
I don't want to learn. I don't want to learn your way though.
You don't want to make compilers?
Ooh, I do. But does people actually use Racket to make compilers? Or is that just something you guys learn about in class? Because I thought everything was made in C or C++.
I mean, that is one question that I do ultimately end up having, because the problem with C and C++ is because they can be object-oriented,
Yeah.
they might have side effects. And that's why usually it's preferred to make compilers in a functional programming language.
Okay.
Because the behavior that you program is going to guarantee to be what you get.
Okay.
Because like one example of side effects was like with the if statement, I guess.
Yeah.
So like when we were defining variables in Racket, where you say let x is equal to some variable, and then you say that variable is equal to the output of an if statement.
Okay.
If you execute the code in the little if conditional expression, it might execute two pieces of code, and those two pieces of code might change the data in some way that you didn't want it to. And so that's where they talk about, oh, the side effects, what we learned about in 330. You don't want to have that, because I think it would be better to like do some of these programming things in like higher languages like C or C++, because they give you so much more information to write way more efficient assembly instructions. Because what we're doing with Racket is whenever we write out assembly instructions for something,
Yeah.
you write out assembly instructions for everything, even the cases where you don't want to run them. But for the cases where you don't want to run them, what you do is you make a label and you jump to that label to skip all the other instructions in assembly. So that's basically what we do in Racket. It's just a lot. We're using Racket to write down a lot of sequential code that should be compiled and run. And it gets a little bit trickier to do some stuff like when he talks about variables, because when you want to define multiple variables like, oh, X, Y, Z,
Mm.
you're supposed to keep a list in Racket that has X, Y, Z. And then in the assembly, you're also supposed to write down where they are in well, they're only going to be on the stack, but you don't know where they are going to be on in the stack. The only way you know where they're on in the stack is by figuring out where you are in the Racket list. And then based on where you are in the Racket list, then you can use that as an offset to see where you should go in the stack to get that value.
Okay, I'm kind of following. Okay.
Yeah, so it's just like it gets harder because the first project that they give you, it's just a Racket primer where they ask you to do a bunch of simple functions in Racket.
Sure.
And then the next project is a compiler project where they ask you to make a whole bunch of different assembly instructions with Racket. It is like that from there on out.
Okay.
It's
Yeah,
just
maybe,
like,
maybe that's something I could look into.
yeah. To me, it was fucking hard as shit.
Yeah, it doesn't sound easy, really. I'm not gonna lie. That sounds pretty hard. Oh man, there's only 2 minutes left too. All right, I think I'm gonna leave this here. I don't know if I really want to continue right now. My mind
Yeah.
is fried.
I'm gonna save my solution as well and work on it later, and I think I'm
Yeah,
gonna
that
maybe
sounds good.
cook something. Yep, it was
You wanna
nice
meet again?
reviewing with you.
You want to meet again tomorrow?
Yeah, sure. What time?
Same time?
Yep, that sounds good with me.
Okay, let's do it.
All right. See you tomorrow, Brian.
Yeah, see you,
Bye.
Rudy. Peace. Alright, let's go. Yeah, this is cool. This is an interesting problem to have, and definitely is a good refresher on some of the recursive stuff I need for Python. So I think maybe later today I might continue going over this problem. Or I might wait for tomorrow. Depends whether or not I have time. Probably gonna head back to the hub right now, and then drink some water, get some tea, and then work on the other stuff I have on my list today. So let me write this down into the host. Oops. Brian's life. Week 1. Okay. So working on LeetCode with finish working on LeetCode problem. So this was the to sum, I think. Add 2 numbers. Okay. Okay. Think back to the Alright. Okay, I'm gonna end the stream now. And yeah, I'll see ya.